Hello. So I was assigned chapter 23, problem 38, and problem 38 is on section 4, resonance in electric circuits. So the problem reads that in a series RCL circuit, the generator is set to a frequency that is not the resonant frequency. This non-resonant frequency is such that the ratio of inductive reactance to the capacitive reactance of the circuit is observed as 5.36. So the resonant frequency is 22.5 hertz. What is the frequency of the generator? So we have the inductive reactance ratio to the capacitive reactance. It's 5.36, excuse me. So the XL to the XC is 5.36. So we're looking for the frequency of the generator. And the ratio can be set up as XL over XC in a mathematical way. So we know that our XL is 2 pi FL and our XC is 1 pi FC. And we find these formulas within section 1 and section 2. So this is the inductive reactance and this is the capacitive reactance. So those are going to come in handy. So once again, our F sub 0 is 22.5 hertz. So now that we have our two formulas, we plug them into the ratio. So it's going to be 2 pi FL over 1 over 2 pi FC. So that gives us our final formula of 4 pi squared F squared LC. So we are looking for our F. So we are going to withdraw the F from there. And that gives us the square root of XL over XC times 1 over 4 pi squared LC. And once we square root it, this comes out to be the resonant frequency, which we have. So that's perfect, actually. And so that just leaves us with the square root of XL over XC. So our final formula is F equals XL over XC times F sub 0. So since F sub 0 is equal to 1 over 2 pi LC, that works out perfectly. And we just plug in. So XL over XC is 5.36, and we just square root that, and we multiply that by 225 hertz. And that gives us the final answer of 520.9 hertz, which we then round to 521 hertz. I like this problem, pretty simple. You just have to know how to manipulate the multiple formulas and where to plug them all in. So we use this formula, and we also use this formula as well as this formula. So it worked out pretty well. Thank you.